This is the Rhino 7 for Windows getting started, and I'm Mary Fugier, and I'm your instructor for this course. The class is designed to take a new user from looking at the blank screen, the user interface, which there's a lot going on there, and take you kind of through the parts of the screen and creating a few simple geometries in Rhino, and then very quickly into this project. So our project for today is the guest house, and with everything that's gone on this year, I think our houses are feeling a little bit small. So I came up with this design for today. It can be a studio, or it can be a guest house in your backyard, and we will go through creating the geometry and rendering, and then eventually we'll talk about layout. So that's our plan for today. I'll show you a little bit more about that before we here in a moment. But before we get started, if you want to know what I would like you to do today, Dell Guy here is going to help me show you that. And what I'd like you to do is, of course, download the materials for today's class, and that's on your materials panel. Make a folder, unzip them so you can be ready to open the files that I am. And if you look here, I have a folder, I call it June 21st Getting Started, and I downloaded the zip file from materials and I put it in here. So now I'm ready to open those files. So as we're getting started, if you could do that, you'll see the materials panel on your Go to Training, and there's files for today's class, June 30th. Download and get those ready. So I don't expect that you should be able to keep up 100%, because I do need to do some prep material before we go into the project, and then we're going to do the project, but we're going to be moving at a pace so that we can get through this in 2 hours. If you have two monitors, it's really helpful both during this session and reviewing the videos, so you can have Rhino on one screen, the video on the other. So then the other links that I have on the materials page are the previous getting started. Now, I've had requests to do an architectural example. That's what I'm doing today. But if you prefer one of the product design tutorials, then we have you covered, because we record all these. Kyle Hutchins and I do them. We take turns, and you'll find product design videos that Kyle has done. So between what we're doing in today's class, with I think even if you are in a different field, you'll find that having a little bit of background in how you would approach an architectural model will also be helpful. There are Rhino 6 getting started. Again, more product design in nature, but very good exercises to go through. And Rhino 6 and 7 are very close. So you can do a Rhino 6 tutorial in Rhino 7 and get through it 100%. Now, I want you to see this model. This is just the one that I did getting ready for the class. If I double click here on the perspective view, you'll notice that I have the model, but I also have top, front, and right views of the model. So I get to look at it from all of these parallel views. And then I have the perspective view that I can look at the 3D model. The perspective view is in render mode. So I can put it back in shaded mode, and it looks about like the other views. But if I put it in rendered mode, I get to see the materials that are actually assigned over here to the layer. Okay, so I'm going to have you open up a file that has the layers already created, so it will take a little bit of the pressure off some of the organization. But I want you to see how a good layer structure is going to help you organize your geometry and then be able to assign materials if rendering is your goal. And I think A lot of times these models have dual purpose. So I can take this model downstream to working drawings at this point, or I can create a few different renderings to help the client determine what the materials are and the color scheme. I can also get some feedback from the client, like maybe the porch is too big. That's one thing that went through my head after I did the model and I looked at the floor plan. The efficiency suite is about 180 square feet. So it's very small, but it has everything in it. It has a kitchenette, it has a shower, bathroom. You can put a bed or you can put a desk depending on how you're going to use it. So, and it has some nice tall ceilings, so it's going to give us that spacious effect. So it's about 16 feet high. And that is, so that's our design, but take a look at this. When we go to page 1, I have included in the set to download a PDF, and there's the PDF that I produced from this model. So we've got our dimensions, we've got views of the different sides of the model, we've got a nice rendering so that we know what our goal is for this design. So anyway, this is a PDF, and it's produced directly off this model. So Rhino 7 has a PDF writer, so you don't need to have Adobe or any other third-party software, but you can write this PDF out directly from Rhino. And then another thing we did here is we used a clipping plane to clip down the floor plan about 4 feet from the finished floor level, and that way we can see the walls. This is all 3D. Okay, so I haven't done any 2D curves here. I used it to build geometry, but when it comes to this layout, page 1, everything here is 3D. So I can double click inside here. You know, I can pick on the window, I can pick on the door, I could change materials. I do have the viewports locked. So when I'm zooming, I'm not changing the scale. And if I pick on the detail and I go over here, you can see it's 1:48. And if you work in feet and inches, which some of you don't, I understand that, but for this class we are using feet and inches. Maybe I'll do this again with meters, but typically what I find is that if you use meters, it's easy to think of this, to redo it with meters, and I can give you those dimensions. It's 1:48, so 1 unit to 48, 1 page unit to 48 model units. So about 1:50, but we display it in the imperial format. So what I could also do with the dimension, and this is kind of fun before we get going here, I can turn on an alternate unit. And if I turn on the alternate unit, I can display it in decimal meters. And then I'll pick OK. So now, I mean, it makes it a little bit more complicated here. So I'd have to do a little bit of shifting around to get that to fit and look good. But that's an option, and I can put in meters. I can also change my unit here to meters and put in a suffix of meters. And now when we go, I've got to increase the resolution. Okay, I think linear resolution, let's go 0.01. Anyway, I'm kind of messing this model up, but I want you to see that you can certainly model this in meters and come up with, in your unit system, and come up with the same model. And the dimension style lets us do that. It lets us show both or change the unit. We're not changing the unit of the model. Okay, so that's our project, and what I'd like you to do first is one of the PDFs that's in the folder is called Commands to Know. And if you're learning Rhino, this is a great way to go through commands that most users need to have experience with in order to model. So that can be a way that you can isolate commands that you may need to work on. Okay, let's go to Rhino, and you may be in a new model, and that is totally fine. I'll begin one with small objects, inches, or small objects, millimeters. It actually doesn't matter at this point. I just want to go over a few of the basics before we get into our project for today. And once you are in Rhino, you'll see that you've got a menu across the top, and the menu actually exposes the hierarchy of geometry in Rhino. So we have curves that we use to build surfaces, and surfaces that we can extrude into solids and poly surfaces. So that's going to be a theme of today's class. So the menu does a nice job of organizing that. We also have some tab toolbars at the top. Standard is typically probably where you are, but you can also go to Curve Tools, and Curve Tools changes the sidebar, and we're going to be using this command up here, offset curve, a lot. So just so you know where that is. If I go back to standard, you can see it updates that sidebar. So a lot of these tabs will update the sidebar. So just be aware of that. If you go back to standard, then you have pretty much your typical toolbar that you're probably used to seeing. What I want to do here is tear off one of the toolbars so it is available for us to use, and this is the OSnap toolbar. So if I press on this button, I can grab it from the title bar and I can open up the OSnap toolbar. Object snap onto existing geometry. And a lot of the times down here, we are just using running OSnap, so it's always available, like endpoint, intersection, maybe center, and of course midpoint. I use that a lot. But there's some specialty OSnaps like between that we're going to use to put together this model that I want available. If I were typing it in a lot, I would make an alias for it. But another way to get to it is from this toolbar. So I can drag it up here, and I can stretch this out so I can see it. And now I can get to, if I make it big enough here, I can get to between, and there it is right there. Okay, so any of these toolbars, maybe you want to tear off the set view toolbar. If you have another monitor, you can drag it over there. But this is a great way to set your views, your named views like top, front, right, perspective. Okay, and some other good commands that are great to get to. So anyway, you can tear off toolbars and keep them available if you use them a lot. Another toolbar that I use a lot is the display toolbar. So I can drag that one up at the end here. And maybe if I think about this a little bit more, I'd put the display one at the end, and I'll dock the object snap one at the end of the command line. So there's a lot of extra space in the command line, and I don't have much extra space in the toolbar. And there's that between OSnap, and you can see the tooltip come up. Okay, so then we have our viewports. Again, when you looked at the model that I had already completed, you saw the top, front, and right viewport in these views, I should say, in these viewports. So this is where you'll be creating your model, and below the viewports are tabbed are tabs that you can switch very quickly between the active viewport. Doesn't make a whole lot of sense when you're in 4View, and it doesn't make a whole lot of sense until we open a model, so I'll come back to that. Then you have your O-snaps. Below there you have your status bar. The status bar is a very nice way to change to a different layer. And then we have our modeling aids. And for right now, you can turn all of them off, and we'll kind of add them in one at a time as we need them. Off to the right is our panel area. And if you close your panel, you can always open it back up again by picking on one of these commands up here that use a panel. So now that it's closed, all I have to do is pick on properties and it opens it back up again. And there are some default panels that are open from the first time we install Rhino: properties, layer, display, and help. This is an extra one that I have open, so I can right click up here and I can turn off environments for now, so it looks a little bit more like you have on your screen. If you type in a command, so let's say you're starting one of Kyle's videos and he starts talking about the loft command. So you type it in, but you don't know where it is found. That's where the help comes in. So if you pick on the help panel, then you will get information, even videos about using the loft command, but it also tells you where to find it. You're going to find it on the surface creation or the surface sidebar, and on the menu, you're going to find it on the surface menu. So that can be a lot of really good information if you're watching a tutorial and the person teaching the tutorial doesn't use the toolbars, but you like to. Okay, and so when I'm teaching, I'll show this to students, and you know, for the first day, I'll tell them where a command is, but after that I won't, because it's here. Everything you need to know about a command location is in the help file. So Rhino does a great job of that. If I go up to surface and down to sweep 2, the most important thing that I see about the help window here, and if you don't have it open, right click and open it. So there's a lot of options here for panels, and we only have 4 open by default. But if you happen to close it, just right click anywhere here and open it. You can also go up to panels and open it. So you should be able to get that open without too much trouble. Now it shows you what the icon looks like. So if you go here to surface tools and you're looking for sweep 2, it's right there. Okay, so a picture's worth 1,000 words. Instead of going glassy-eyed looking at all these icons, make it easier on yourself. Okay, look at the help, find out what you're looking for, and then you can very quickly isolate that button. And it tells me it's on the Surface Tools sidebar, so I can get there again pretty easily. So help is going to be really important after the training. Let's open up a panel called the Tutorials panel. And if you right click on any of the tabs, you'll get to it, or you can go up to panels and down to tutorials. Now the tutorials panel is where you will find additional tutorials, PDF tutorials, for you to do after this class, or maybe you've already found them and done some, that's great. But the user guide is actually the place to start. So you can see the user guide for Windows. If you pick on it, it will download and open the PDF. And then in the PDF, it will tell you to open up the headphone file or the join curves file. So you can go through this. Everything is here that you need to do the tutorials in the user guide. The level 1 and level 2 get progressively more difficult, but the concept is the same. There's a PDF and there's files that the PDF refers to, and those are all here. So in the level 1, if you scroll down, you're going to find a file called What is Rhino? And if you double click on that, it will download a file that shows us some of the objects and geometries that we're going to be creating in Rhino. Or if you open up an existing file, you might find an existing file with these types of objects. So we have annotation objects, dimensions, and text. We have curves that are 2D objects that can be used as input for 3D objects. We have surfaces that do not have volume. Surfaces can be joined together into poly surfaces. Again, they don't have volume. So if you need to 3D print, 3D printers rely on closed poly surfaces that have volume. So you're going to have to figure out how to turn that into a closed poly surface. And one easy way to do that is with the offset command and the solid option. We do have solid primitives though. So you can create a box, or you can create a cone, a truncated cone, a pyramid. You can extrude geometry. We also have point objects, and we're going to use this in our project for today. If you're just arriving, make sure and get the files for today's class off of that materials panel. There are surfaces that are not poly surfaces. I can't explode these, but they do form a closed volume. So the sphere and the ellipsoid cannot be exploded, but they do have volume. And then we have meshes, and then we also have sub-D objects that there's videos out there on that, but they are part of Rhino's collection of geometries. And you can see that up here. There's a sub-D menu. There's also a mesh menu. Rhino will import meshes. So if you have 3D Studio files, or you go out to Google Warehouse and you get a sink or a shower for our guest house, then you can import those into Rhino. They are different. They don't have all the options and flexibility that Rhino surfaces have. They're a little bit more of a rock, but we're getting more and more options in the newer versions of Rhino. So if I need a sink from Kohler, I don't need to edit it. I just go out to Kohler and get a sink and bring it in. So there are lots of cases where you just want to add to your model, but you don't need to edit it. So that's where meshes can be very helpful. Also, meshes can export to STL as well as our geometry. So if the goal is to 3D print, if it's a closed mesh, then that can go right out to your 3D printer format, usually STL or OBJ or DXF or DWG. Okay, so if I have a curve and I want to turn it into a surface, that's very easy. Up here under surface, I can extrude that curve straight. Okay, so I can do that with the extrude command. Okay, there's also a tool that we're going to look at in Rhino here called the Gumball. And the Gumball allows me to move. I can just grab the arrow and move that curve around. It also lets me copy, so I can hit the Alt key and copy this curve. I can rotate the curve using the arcs. I can rotate it off the construction plane, or I can rotate it on the construction plane. And the Gumball also has a little widget on it that I can use to scale geometry. Now, not just a curve, although we're using a curve in our example. The widget lets me scale that object non-uniformly or uniformly if I hold down the Shift key. And the Gumball is going to be our right-hand man here as we're creating our model today. So get Gumball on, and start getting used to selecting objects with it on, because if I go to move a curve, I'm going to use that gumball. Now, if I want to move it accurately, I might move it 2 units. I can type in on one of the gumball arrows, I can type in a distance to move this relative to. So it's not just a visual move, it's you can type in a relative distance. There's also the move command, and if I go up to transform and move or pick it off the toolbar, I can move this curve from this endpoint to another endpoint. So let me get my O snaps turned on there. So sometimes we need to do a very accurate move endpoint to endpoint. Okay, so I closed in that gap by doing that move. Okay, sometimes that is really important. Also, when you pick on a curve, you'll see that there are control points, and those control points can be used to modify the curve. So instead of moving the curve, I might just take that control point and just drag it right over to that curve. Okay, so now these curves are meeting at that point, but what if I wanted to turn them into one curve? Okay, join. I can join these together into one curve. Now when I pick on it, you can see that it is one curve. I can also explode it back into its component parts. But the other thing I wanted to show you about the gumball, remember that extrude that we did? We can use the little balls that are here on the curve to extrude it into a surface. Okay, and if I extrude an open curve, it creates an open surface. If I extrude a closed curve, again, it creates an open surface if I do it with gumball. However, if I do solid extrude planar curve straight, this one by default will have a cap on it. Okay, so this is how we get from curve geometry to 3D geometry, is by using the curves that we create as input for surfaces. And the modeling aids of object snaps and the gumball are going to be really important to our project. If I double click on perspective, I get back to the 4 view. If I double click on perspective again, you can see I can move between my viewports without having to return to the perspective. Now, return to the 4 view. A couple of other modeling aids. We have a grid snap, and if I start a command like Polyline, notice how I'm picking on a grid snap, and I'm on this layer called polysurface. It's really hard to see, so I can make, a surface layer current or dimension, just anything. So when I'm picking here, I'm not allowed to pick anywhere but on a grid dot. Okay, so that's called grid snap, and we can close that up. You can change your grid by right-clicking on it and going into settings. You can change what you're snapping to. Right now, we are snapping to 1 grid spacing, and our minor grid lines are at 1. So if I put in a 2 here, it's not going to change my grid, but then when I start to snap, I'm only going to be able to snap a distance of 2 grid dots. So those things are independent. Okay, so that's grid snap. I'll turn that off for now. The other option that I have here as a modeling aid is called Ortho. And if I turn Ortho on, it restricts my cursor movement to horizontal or vertical. And that can be great, but what if I wanted to draw at an angle of 45 or 60 or 15? If you right-click on Ortho and pick Set Ortho Angle, you can type in 45. Okay, now when you take your polyline and you start to draw, you are snapping at 45 degrees. Okay, and you can drag your cursor around and pick. I'm not combining this with snap, but I could. I could turn snap on, and now I have both ortho and snap. So I'm restricted to 45 degrees, but I'm also restricted to picking on a grid dot. The one that I like to use for ortho, if I right click on it and set angle, I like 15 degrees. And with 15 degrees, I can get to the 45 degree increments, but I can also get to the 60 degree increments. So right click on ortho, set ortho angle to 15. But as you add more increments to your ortho angle, I'm going to turn snap off, by the way. How do you know you're on 15 or 30 or 60 or 45? It's very difficult. So that brings us to another modeling aid called tooltips. So I'm going to go to the yellow gear here, which is options, and I'm going to turn on my cursor tooltips. So under modeling aids, there's a little chevron there. Pick cursor tooltips and turn on distance and relative point angle and watch what happens. Okay, when you're looking at options, there's one thing that is really important to know. Anything that you change in this area is being saved with your model. Anything you change in this area is being saved on your system. So when you put the check mark in these two options, distance, the other one was checked, and relative point angle, then Rhino's going to remember that. So tomorrow you won't have to do this. It will already be set. So I'm going to pick OK and take a look at the difference. This is going to be really helpful as we're creating our guest house. When I point my cursor up, I get the distance and I get the angle. So now I know I'm locked on to 15 degrees or 30 or 60. Okay, so if I type in 10 and then pick, I'm going 10 units. If I type in 10 and then pick, I'm going 10 units. If I type in 5, okay, and enter, and then pick, I can lock on to the angle that I want to use with ortho. So this is called distance constraining, and it involves locking onto an angle, which ortho's helping us with, typing in the distance like 10, and then enter. And after it locks you onto the distance, if you don't like 10, you could type in 5, or I'll go back to 10. And then you have to pick to lock in that distance. So that's called angle constraint. And when we're in the architectural model, that's going to be very important to make sure we get geometry that is the right size and in the right location. That's secondary because I can always move those objects. Okay, I think that we are ready to go ahead and start today's project. Let me show you. I don't need to, I guess the only other thing I wanted to show you here is that all these curves can be extruded into geometry, or we can create a planar surface out of them. So if I go to a different layer here, how about the points layer? If I go up to surface, I can create a planar curve, or create a planar surface from that curve. Okay, I can also go to solid and extrude planar curves straight. Okay, and I can do some other things with these curves. For example, I can go to surface and revolve. And when I revolve a surface, around an axis, let's say full circle, then we create a closed poly surface. And if you look at this, if I pick on it and go to properties, it is a closed poly surface. Okay. Okay, so I wanted to show you one more thing here that I think you'll find useful. And that's called history. So history will create a relationship between your input curves and your output geometry. So take a look at this. If I record history and then I go up to surface and revolve, I'll pick on the curves to revolve and I'll pick the axis just like I did before. And I can give it like 0 to 180, or I can just do full circle again. But what I want to show you is that there is a relationship between this curve now and that surface of revolution. So as I move that in, you can see it changing the poly surface. And if I do something like stretch it, okay, so history, history is a relationship between the input curve and the output curve. So and it's a one-way relationship, one-way street here. So I can't change the poly surface and have it update the curve. The curve is what updates the poly surface. So anyway, there is a lot of information. I don't know if we're specifically going to use history in our model, but if I type in history here, you can get the explanation of what history is. You can also look at all the curves that support history down here. Okay, so if you think that history might be really useful in the way that you model, which I'm sure it is going to be useful, take a look at the commands that support history in the help. Okay, homework. So I'm not going to, I didn't really do anything to change here, but in the zip file, there's a file called surfaces.3dm. And what you want to do with this file is just get a little bit more practice with surfaces, and you can do an extrusion, an edge surf, a loft, a sweep, and a sweep too. Okay, so if you were going to do edge surf, what you can do is type in edge surf, and then you can watch the video over here and you can find out where the command is and so on. So that's a little bit of practice for you creating surfaces, and we've already created a few of those, but let's do the 2 rail sweep. So if I do sweep 2, pick on the 2 rails, pick on the 2 cross section curves, and then we get options for the command. I'll pick the defaults there, and then we get a sweep between those 2 rails and that geometry. Now, if you look back under history, you will see that 2 rail sweep supports history. So if you turn history on before you do the sweep, then you will be able to change your input curves and have that sweep update. Loft also supports history. So if I do a loft, a little bit different surface, it's not as strict, reducing, and that one I twist it. So this time when I loft, I'm going to pick on the same edge of the curve, and I'll make sure history is on before I do it. And now when I move the curve, you can see how it changes the output surface. And if I come in, it's really hard because it's blue, and rotate that around and move this, the surface update. So history, super cool feature, and allows you to really design as you're modeling. Okay, so I'm done with that. Let's go ahead and open our project file. And it was in that zip file. It's called My Shed Start Here. Shed is probably a little bit of an understatement, I should say. It's a little bit more than a shed. And to remind you what we are doing, here is the PDF of the studio building, and more or less, I'm going to reference these dimensions, but you know, if I decide to something needs to change, I'll let you know. But more or less, these are the dimensions that we'll be using. So I'm going to put that over here on my other screen. This is live, so you never know what's going to happen. Just warning you. If we find ourselves heading down a dark alley, then we're just going to have to figure it out. So just like you do in real life, this isn't, it's been barely rehearsed, just enough so that I could have a model ready for you to save a little bit of time as we're putting it together. You could also try doing this from scratch later, or doing something similar. Model your kitchen, as I say, is always really good modeling practice. So the top view is where we'll start. So if you want to double click on the top view, I have some points here to help us get the geometry located in the same location. So not necessarily, doesn't really have to be there, except I do have a couple things that are going to rely on all of us having this in the same location. So if I look at the PDF file, and sometimes I'll take a screen capture so I can just bring it in there. You can see that it's 16 feet by 20 feet is our overall platform for the building. And then at 8 feet, that's our porch, and then our building is 16 feet by 12 feet, the interior. So that our exterior walls are going to be 6. I've got plumbing, I've got electrical coming in here. So and I want to insulate. So I'm going to have a 6-inch exterior wall and then 4-inch interior wall. So again, like I said, it's a pretty, it's going to be a pretty nice structure, and it'll have a kitchenette and a bathroom. So anyway, we're going to keep that in mind here as we're creating the geometry. I want to be on the layer here called base curves. So if you look over here on your layer panel, you'll notice that I've isolated the geometry from the curves, and this can be a really helpful way to organize your models. These are called hierarchical layers, and to create a hierarchical layer, all I have to do is drag the layer onto another layer, and it just kind of drops under like a sublayer. Okay, I can also make a sublayer, but if I don't want it to be a sublayer, I can just drag it out or use this button up here to bump it out so it becomes just a first level layer. Okay, so base curves is the current layer. And let's go ahead and start with a polyline. So if I pick here, I want to be able to snap to that point. And I need to turn on my 0.0 snap and pick here. And I want to go out 16. Now, if I don't put in the foot mark, I'm going to get inches. So I have to go out 16 feet. The foot mark communicates that unit to Rhino. And then I want to go up 20 feet. Notice how my feet and inch display is actually in inches. So even though I'm typing in 20 feet, it's communicating on the command line that I am 240 inches, which are equivalent. So I'll pick there. Okay, now I'll go over 16 feet Okay, and then I'll close that up. So that creates the pad for the building. Under walls exterior, I want to make this layer current because I want to now identify where the building is going to sit on this pad. So one thing I can do is start the rectangle here, and the width of the rectangle is 16 feet, and the depth of the rectangle, if I didn't have anything to pick on, I could type in 12 feet. But it turns out, since I've been so helpful here, using the point and the corner actually create the rectangle the size that we need. Okay, let's go back here, and we have the curves, but we don't have the geometry. So starting with the base layer, let's extrude this curve into a concrete pad, and it will be 6 inches, a negative 6 inches in depth. So if I highlight that curve up under solid, extrude planar curve straight, okay, in the right view, okay, you can see where it's extruding. I'll keep my cursor there, but I'll type in 6. That locks in 6 inches, and now I've created the pad where the house is going to sit, okay? So that's a good start, but when I extrude the walls, I'm not going to extrude it into one big old block. I need wall thickness, and I need an area inside that's going to be the interior. So we're going to go up to curve and down to offset, and I'll offset the curve on the inside by the exterior wall thickness, which is 6. Now notice it's going onto the current layer, so I want the exterior curves layer to be current, okay? And let's see if it does do it. Okay, so now we have, I just wanted to make sure it put it on the right layer. If it didn't, we can always change layer here. When the curves are selected, we can change them to a different layer using that control. We can also change them to a different layer using object properties. So if I put them on, you know, the framing layer, or I don't want to put them on a layer I turned off, so I'll just keep them on this layer. Like I said, we now have the curves that we want to extrude into the exterior wall. So I'm going to pick both of them, and up under solid and extrude planar curve straight, notice that because I'm picking coplanar curves that form an interior island, the extrude command is differencing out that area. So this is perfect. So now I'm going to have the exterior walls, okay? And the only, right now it is an open, let me go ahead and make sure. Oh, it is closed. Okay, so it does have a cap on it right now, but we're going to change that here in a moment. And the way we're going to change that is we have a curve here that's actually setting the slope of the roof, and the walls are going to meet that roof. So I have a little bit more exterior wall than I need. Okay, so this isn't a rectangular building. It's actually going to have some slope, and it's going to slope down in the back, so that the ceiling height in the back is about 10.5 feet, while the ceiling height in the front is at 16, just about 16 feet. So let's take a look at a command called trim. And trim is over here, and trim asks you to pick cutting object, and that's my cutting object, and enter when done. That's a very helpful prompt there. So I'm going to enter when done picking the cutting object, and now I pick on the part of the wall to go away. Okay, and when I do that, you'll notice that it opens up the poly surface. Fortunately, it opens up the poly surface with a planar opening. So if I go up to solid and down to cap planar holes, it caps it with a surface, so now it's a closed poly surface. Not necessarily 100% necessary, but by having a solid, if your goal was to 3D print this, then you would keep pushing that forward so that you did not open it up into a poly surface that had naked edges, which would cause problems for your 3D printer. Okay, so that gives us quite a bit to go on. And let's use this line. This is also the edge of the roof. If I didn't have this line here, I would have you take the exterior curve here, extract the curve, join it, offset it 2 feet, and that would also get us to the edge of the roof. But this line is going to give us a little bit of a shortcut. So up under transform, I'm going to mirror it over the midpoint. And if you don't have your midpoint snap on, get it going. And ortho is also really helpful. Now that I have these two curves, I can loft between them and start building the framing for the ceiling. So I'll make the framing layer current, and up under surface and loft, I'll loft between them. And just use the default. So now I have a surface that will, the framing will be built on. So my first reaction here is to, there's quite a few ways to do this, but I'm just going to show you one common way. Up under solid, I can go to extrude curve straight. Now, actually, I was close. I don't want to extrude the curve. I actually want to extrude surface. There we go. We have a surface. I want to extrude it straight, but take a look at what's happening. Okay, it's extruding it perpendicular to the planar curve. And that might be an option for the style, but let me show you another one that might be a little bit more dramatic. If I choose direction, I can pick 2 points. It doesn't matter where I pick, I'm setting the direction, and I can extrude it perpendicular to the construction plane. And for my house, or my guest house, that's the style I'm going to choose. So I'm going to type in 10 and then pick. Okay. So I now have the ceiling and the framing for the roof, but I do need a roof layer. So let's take a look at a command under solid called extract surface. And extract surface with a copy will make a duplicate copy of this surface so that I can model from it. It's extremely useful. So I'm going to pick that. I've got the roofing layer current, and copy equals yes. So I think we're good. Now, if you look at what I have here, I have a surface. It didn't quite read the roofing layer, so I'm going to put it on the roofing layer. And like we did with the framing of the ceiling, I need to extrude this to 2 inches. So let's go to solid, extrude surface, straight. Okay, do direction, pick 2 points with ortho, and when you get it extruding in the style that you want, type in 2 for the roofing material. Okay, so we have the roof done, the first roof. We do have an overhang. We'll work on that here in a little bit, but let's place our focus now on the front of the house. And I'm going to make the door layer current. And although the door is going to be 2'8" in, I'm going to create a rectangle, and that rectangle will start right here. Okay, and then I'm going to move the rectangle into place. So I'll pick the start point. Notice how center is getting in the way a little bit. If it does, you can turn center off. Then I'll go back to front, and the width of the door is 36. The height of the door is 80, and now we have our door. Okay. The door, though, isn't going to be there, so I'm going to use Gumball to move this over 2'8". Great. Okay, we have our door. And we have a window that we will do in a similar fashion. One of the options, so I have 2 foot from the corner. So one of the options I have is to create a 4 foot window. But if I put in a -48 or 4 feet, either one, and then a positive, -48, enter, and then 48. Okay, so there's our window, but it's obviously not in the right place. I do want to move it over 2 feet, but not 2 feet in that direction, -2 feet. And now I need to move it up. Okay, so how am I going to make it level with the door that is 80 inches off of the base? There's another modeling aid in Rhino called Smart Track that would be helpful here. But if you didn't know about Smart Track, let's just say you draw a line. And now I can move this from the corner up here. Okay, so that would be a totally valid way to go. But if you want to get more sophisticated and use the Rhino tools, if I turn on Smart Track, I can move, M for move, from here, but not to there. So I'm going to just drag my cursor off to the right, and that line that you see is a tracking line, and I can snap my cursor anywhere along that line. Okay, so the mechanics of that are move from wherever you want to take it, pick a base point, and with Smart Track on, guide your cursor over a point and guide it away. Do not pick. If you pick, then this curve is going to go at that corner. And that's the problem that I see with starting to use Smart Track, is that it's not a pick, it's acquiring. You put your cursor over and move it away. That will take a little bit of practice. So if you don't have time to practice, just draw a line. It's perfectly good, and then delete it. It's just some construction geometry that will be really helpful, keep things accurate, and then keep you moving forward. Now, the window looks like it's out here, so I need to move it, and there's a couple ways to do that, but because I'm actually going to use this as a trimming curve, and the trimming curve is going to be extruded, I don't have to be really worried that it's not on that it's on that surface. If I did, I would project it. But since I'm going to be using it for trimming, I can move it back, and I got it, nearly on that surface, and that will be perfect. So I'm going to pick this curve, and I want to create another one. So I will mirror it at a 45-degree angle, so I have that window on the other side of the building. And I want to take this window and copy it 5'6". Okay, so if I do transform and copy, I can pick it, and the distance that I want to copy it is 5'6". Okay. Now, another way to do that I prefer is to use the clipboard, Control-C, Control-V, and then just use the gumball. So if I type in 5'6", I had a copy that I was able to then move up to that location. The curve is going to come in handy again here. I'm going to use Gumball to copy it, and I'm going to grab the corner of this window and move it up. I want to follow this window to follow the same slope of that curve, and that got us right on that curve. I probably don't need this again, but I can cell curve and delete all my curves later. These curves, however, are going to be used on the other side of the house. So what I'm going to do is transform and mirror, and I'll use a midpoint of one of the geometry so that I have the windows on the other side of the house. And the last window that we need to create is 12 foot long, and it's 2 foot high, but minus 2 foot will get us that window. And if you pick on the window, you can move it, and you can move it from the midpoint. I'm going to get rid of center. It seems to be causing some trouble. And then once I get it here, I can start looking for some help. And what I want to do is grab a curve that will wrap around the house. So I'm going to take some construction geometry, and if I want it to be the same height, now I've got a overhang coming in here, so I might want to use that, or I might want to keep it kind of where it's at. I think what I really would like to do is, instead of using that curve, I can project it onto the surface of the house. Let's go ahead and do that. I think that would be pretty worthwhile. There's a command called project, and you can look in help and find out where that is located. I want to project this curve onto this surface. Okay. And when I do that, you can see over here now, I've just about guessed perfectly where those curves are going to intersect. I could just move it up a little bit so that those are lining up. So it's in the same plane as that projected curve. Okay, I don't need that, so I'll go ahead and delete it. And I think that will work for the location of this window. Now, the windows do get a little bit tedious. I'm just going to warn you. I'll go through them as quick as I can, but I think a little bit of repetition is really good when it comes to the windows. So this curve, I actually will keep around, but I don't want to look at it, so I'll pick hide up here. Okay, so now it's hidden. And let's start cutting the holes in the exterior wall. So I'm going to start here on the front elevation, and I'll pick all 3 curves. And we're going to use a special command here called wire cut. And wire cut will cut through the solid geometry, and it will keep it closed. You'll find it under Solid, Edit Tools, and Wire Cut. And Wire Cut says select objects to cut, and for me it's the exterior wall. And I'm cutting in the world Y. So if right here where it says cut depth through object, I could do normal to curve, which works out really well, but I could also pick the direction and then pick on Y would also work. But let's do normal to curve, and I'll pick both sides equal yes, just to make sure I get a clean cut, and keep all. You can do yes or no. It might save you from deleting them if you do no there, but you can see now it's a little scary at first to keep both pieces and delete what you want, but you can see now we've cut through the exterior wall. And we're going to do that again with these curves here. And with these two, I can actually cut all the way through. So if I do wire cut again, and the objects to cut, I'll pick on the exterior wall, I can actually cut them all the way through. And when we do that, then we have both sides cut. Now, the last thing I want to do is take this window. I want a little bit more light in the back of the house. So I want to copy this curve. Actually, mirror is probably a good way to do that, special form of the copy command. And then once I have this curve, I want to bring it down and place it, about a foot under the eave. We can be as exact as we want to be here, or we can just place it about where we think we want it to be. But if you want to find out where it's at, you can go Analyze and Distance, and you can pick from that corner. And so we're about 19 inches. So if I pick the curve and I go one more unit, it will be 20. Okay, so I think I like that. Let's do another wire cut. So I'll pick on the curve, select objects to cut, and I'll bring it on the inside. Okay, so now we have a window in the back of the house. We have the openings, but I want to look at how to do the framing for the windows. And we'll do a few of them. Actually, all we need to do is one of these, and then we can copy it twice. If we do this one, then we can copy it twice. We do this one, we can copy it in the back, and then of course we only have one door. So let's work with the door. And I have a curve for the door, and I want to copy that so I can use it for the door surface and for the trim. So I'm going to use my Gumball, tap the Alt key, and I'm going to copy it into the center of the wall. Okay, so that will come in handy to create the door. Okay, so I'm on the door layer. I can go up under Solid, Extrude Planar Curve Straight. I want to do both sides. And for the depth of the door, I'll put in 1.25. And when I pick it, the door is just a solid door, but what if I wanted it to be a little more interesting? Well, one option I have is to do a nice window in that door. So I'll do Offset Curve, and I'll offset it. It's already set to 6 because I used it the last time. This time, when I do the Solid Extrude Planar Curve Straight, and I put in 1.25, both sides equal yes, then I have a window in my door. Okay, but I haven't created the glazing yet, so let's do that. Let's make the clear glass layer current. I already have a glass material, so I'll go up to Surface from Planar Curve. And let me undo that because I only want only one curve. There we go. So let's do Surface from Planar Curve. And you can see it's on the outside. Now I meant to grab the one on the inside, but there we go. Let me get back to that because I really didn't want to use that curve. I want to use this one. There we go. Then we'll be in the right place. So Surface from Planar Curve, perfect. Okay, so we have our door, we have a window. And the other thing that we want to do is trim out the door. Now, the outside curve, though, I don't want to trim the bottom. Rhino has a command called delete subcurve. So you can type it in, it auto-completes, and the curve that I want to delete is along the bottom from here to here. So what does our curve look like now? Well, it's an open curve. So how is that going to help us? Well, I don't want trim along the bottom of the door. So I am going to offset it. And when we offset it, this time the offset curve command, I want to turn on cap equals flat. So if it doesn't say cap equals flat, do that. And our trim distance for the door, let's see how 3 looks. If 3 looks a little big, go ahead and change it to 2. I think I'm going to be using 2 on the windows. So let's go with that. And now that I have the curve, it's a closed curve, and I am ready to extrude it into the trim. So there's one more thing I want to do. I want to move it a -1, and now make sure I'm on the trim layer, which I'm on the glass layer. We'll go to solid, extrude planar curved straight. I don't want both sides, so we'll turn that off, and we want it to be 8, so 1 inch on either side of the wall. Okay, so there's our door, there's our trim. The only thing we can add to the door here that I think will make it a little bit more fun at this point, and then we'll go on and do our windows. We can get a sphere, and I like to pick it from up here. I want to do a center radius sphere. And I want to come in a little bit under, and I can measure this, of course, but we can get really close here in this preliminary drawing. And then we can fine tune it later. I can also get a doorknob off of a doorknob manufacturer website, or I can find one out on SketchUp Warehouse or Turbo Squid. So let me get it back on the door. There we go. And then you can create a rosette or something, but that communicates door to me. So let's use that same technique now to create the window. So I'm going to take the curve that's on the outside, and you'll get used to this because I'm going to use the same one for each window. I'll copy it, and this curve is going to create the glazing. So I'll go to surface from planar curve, and I have the glass on the inside of the window. I'll take the outside curve, and what we're going to do with this curve is a little bit different. We're going to offset it, and we're going to offset it on both sides, unlike the door. And when we offset it on both sides, it's going to be pretty thick. Maybe I'll go with something like, I want the total distance to be 2, or maybe 1.5. There we go. So the total distance is 3. Let's see how that works. So there's my trim, and I still have my existing curve, but I want to take these curves and extrude them onto the trim layers. So move them out by 1. Let me undo that. Notice here, -1, there we go. And solid, extrude, planar curve straight, and 8 is the distance, and I want to be pointing in that direction. Now, these curves here are not needed, so let's just pick them and delete them. Okay, so we have that one window done, which we're going to use in the other 2 places. If you highlight everything, you could block it, but for the sake of time here, I'm going to group them together, and we'll group them so that they'll be treated as one. If you block them and give them a name, then you'll be able to count them. So that's also worthwhile, something to try. I'm going to mirror this one over here. Okay, so now I have that other, and I'm going to take this one, and guess what? I'm going to mirror it as well. So mirror from here to here. Okay, so the last, almost last, let's take this curve here, and using our same method, we'll copy it, curve, create the glazing, up under surface from planar curve, take the outside curve, offset it. We'll offset it using both sides, and that one you have to pick every time. You might want to offset it onto the trim layer. Hopefully it'll pay attention to that. Okay, so now that we've got the trim, we'll take both of the curves and we'll move them out by one. Okay, and then we'll solid extrude planar curve straight. It does get easier, doesn't it? And there we have our trim. Okay, so this one, the glass, including the trim, we'll group it together and we'll mirror it to the other side. And we have one last window to do, and that is the front rectangular window. Of course, you can add mullions and anything else that you think would be fun. I will grab the curve, and just like we did before, I'm going to copy it to the center, hit the Tab key, make the glazing layer current, surface from planar curve, make the trim layer current, pick on the outside curve, offset the curve, both sides has to be picked every time, pick, and now that I have my two curves, I'm going to move them one unit, and then we will solid extrude planar curve straight, and we'll go 8 units. Okay, so we've got our window. Let's pick both of them. And there's just one last thing I want to do here that I think is really worthwhile, and it will bring up the topic of between. So I just drew, I'm going to create some mullions here. So I just created this curve, but I want to offset it. And using the cap flat that we have, I want to offset it on both sides. And I might put in a distance of 1, so it's a little bit thinner. And when I do that, I can probably delete that curve. I can extrude this into a mullion and then copy it. So I might want to offset it back a little bit off the trim, and then solid extrude planar curve straight, and I want to extrude it, let's say 6. Okay, so there's the mullion. Okay, I've got one of them, but I need 2 more. Okay, so I want to copy. So I'll take copy, and I want to copy it from the midpoint, and I want to copy it between. So let's get our between snap. I want to copy it between. Now notice Smart Track's kind of giving me fits here. So I'm going to turn it off between here and here. Okay, now I did that to the curve. I didn't do it to the solid. So let's go ahead and delete the curve, and let's use the solid this time. So copy, pick the midpoint. Okay, point to copy to. We're going to go between the midpoint here and the midpoint here. There we go. Okay, now we also want this, looks like we popped it out just a little bit, probably with the point that we picked, but we'll bring it back. And then we're going to mirror this to the other side. And so we have a little bit more sophisticated window with mullions for the front of the house. Okay, didn't take too much longer, but I do want to group these together. So we'll grab the extrusion, we'll grab the mullions, and we'll grab the glazing surface. Okay, that was a lot of That was a lot of talking, so I hope that helped. I'll group them together. Okay, and then we not only want to mirror, but we're going to have to move it down so it fills the opening that we have in the wall. If we left we could probably snap to the corner if I turned on ghosted mode and snapped the glazing corners so that it lined up perfectly. My guess is we're probably going to be able to get super close here just by using the gumball. But of course, ghosted mode and glazing and snapping, if you have to be accurate, Rhino can do that too. Okay, let's look at the overhang, and that's coming off the framing layer. I need to do the same thing we did with the roof. So I've got the curve for the front roof. We need to mirror it, and I want to make sure I get the midpoint of the house. And with the framing layer current, let's do a loft, and we'll loft from here to here. Now that we have the surface, we're going to extrude it. Solid, extrude, surface, straight. And remember what we did before? Okay, we didn't want to extrude it like that. We wanted direction. We pick here, and then we pick vertical. And that's where we can type in 6 and solid, extract surface. This is where I want to be on the roofing layer. Extract with a copy. Okay, so we have a surface that I'll put on the roofing layer. Roofing layer's current, and we'll do solid, extrude, straight. Again, direction. Pick on the corner, pick vertical, and put in 2. Okay, so we've got our ceiling framing, we've got our roof material. I love the placement of the window. That looks fantastic. Let's take a look at the posts. So the posts will also be extruded onto the framing layer. So I need these 3 curves. You would have to create them as rectangles and evenly place them if you wanted to do that from scratch. And I'm going to solid, extrude, planar, curve, straight. Okay, and I'm going to bring it up not quite to the roof, and you'll see what we're going to do here. I need to create a beam. So once I have the columns, I can pick on this corner, and then I can pick over here on this corner, and then I have the rectangle that I'll use to create the beam. And to create the beam, I'll go up to solid, extrude, planar, curve, straight, and I want to put in a height of 12. And you can see that the height of 12 doesn't quite come under that roof. So I'm going to move it up, and I need to essentially cut the beam at the same slope of the roof so those will rest in place. We'll put some brackets on them to make sure they stay in place. But right now, I want to trim this beam, and then we'll take care of extending the other 3 columns. So what I'm going to do is use a Boolean. I'm going to do Boolean difference. Select the positive, that's the beam, and I'm going to select the negative, but delete input no. And watch what happens when I pick the ceiling framing. Okay, it cuts the beam, but it leaves the ceiling in place. So Booleans are really good for this type of work. There are other ways that I could scale 1, but there's a great option here if I hold down Shift and Control. And if I pick the surfaces, I don't really need this curve, I'll delete it later, but I can pull it so that it goes right up under the beam. Okay, and that essentially extrudes those columns. Okay, so now they're coming up under the beam, and in Julia Child's format here. If you turn on the railing, you'll see that we have one railing created for you. It hasn't been grouped yet, but if we group it together, we can mirror it and copy it around. So I'll group it just to make it easy to pick. And I will do transform and mirror, and I'll mirror it on this side. And so now we have one on that side, and then I'll take this and we'll mirror it again, and it'll be on the other side. Okay, and if you want, you can hold down Shift and Control, and you can grab this framing member, and you can copy another one. Okay, now that just ended up with the curve, but I'll do the same thing with the extrusion, Shift and Control, and I'll drag this down, tap the Alt key, and now I can come up with a little bit more secure framing there against the exterior wall. So you can do that even though your geometry is part of a group. It can be selected with Shift and Control. Okay, and if you want that on the other side, you can copy it. I like mirror. I like keeping things symmetrical. There we go. Okay. And you now have your railing, and let's take a look at the materials that we already have set. So if you haven't saved yet, you can go up and pick incremental save, and it will add a 001. And if we put the perspective view in rendered mode, you can see that we have some materials set, the roofing material, and we have a wood on the ceiling. These columns here, I actually put on the roofing layer, which is silly. I need to move that to the trim layer. There we go. Okay, so that looks a little bit better. And we might want to pick a screening material for the railing here. We could fill that in with a material, and it's looking pretty good. Let's turn put a material on our exterior wall. So if you pick on exterior wall, notice it says default material. If you go to use a new material from the library, you can import from the material library. These all come with Rhino. There's over 3,000 materials. You can go to architectural, to wall, and you can pick from all these categories. Okay, so if you go to siding and you turn this into a medium or large icon, then you can see, some options to pick for siding. I'm going to do siding upwards. It's kind of like T111 siding. Pick OK, and you can see, we have that. Looks pretty cool. Okay, so let's look at some other siding options. I have a few materials in the file that I imported the same way. If you go to wall exterior, and instead of going back to the library, you can go through the file, and you can see I have a weathered shingle. And this one does come with Rhino too, so you could go out and get it from that same folder, but I just have it here for you. Okay, what else do we have in our file? I think we have one for stucco too. There, so if you want a little stucco, probably need to make that beige and put our house in Arizona for that to work. So I'm going to go back to either the vertical siding or the weathered shingle. Okay, let's talk about the interior, because when I look on the interior now, there's shingles, and I probably am not going to that expense. So let's make the wall, let's make the trim layer current. That's fine. Any layer but the roof layer. I want to turn off the roof layer, and I want to turn off the framing layer just so we can see inside. Okay, so what we have here, because we modeled so beautifully using the wire cut, we have a closed poly surface, but I don't want the shingles to be on the inside. So here comes sub-object selection, Shift and Control, and I'm not separating this. I'm just going to be able to give the inside surface a different material. Okay, so Shift and Control, I get those selected, and I'm going to go to Properties and Material, and I will pick a material called Paint. Okay, now by doing that, I can now look through the windows and I can see that I don't have the shingle material on the inside of the house, and that is fantastic. And the other thing I can do here is I can go to Layer, and I have a layer called Walls Interior, and I have also an interior window for the shower and the bathroom. I have a door, and then I have a partition wall. So those are done. The kitchen will be on this wall here. I have a layer called Furniture Layout. Now, if we were going to put furniture in here, we'd have to do that in another Getting Started, or you can give it a try. Just download some blocks and insert them just like you were arranging any any geometry. What I want to do is look at this display mode because I'm not seeing the curves, and when I turn the curves off, I can't see the furniture layout. So that's just a real brief kind of description about how I see this interior being laid out, and really great because I've got the plumbing in this wall on both sides. So I've got the shower, the sink, the water closet, everything is on this side, and then I have my kitchen. So that's going to be really inexpensive for the plumber. So that part's good. And let's go ahead and bring back our roof layer and our framing layer. Okay, so all of that looks good. One thing I can do here is Cell CRV, okay, and I can hide all those curves. So all I'm looking at are the geometry. I can also do Cell Point, and I can hide those points as well. Okay, so in the last few minutes here, I want to set up this on a layout and then just show you where you can add a dimension or an annotation or two. There is a screen layer. Right now it's got a plastic that it's actually an opaque plastic. Okay, so I'll rename it so we know what it is. But there are other materials here. There's one that I got from the library called, I don't like that one. There's one here called Expanded Metal, but I don't like that one. You can see it. It's, oh yeah, that is the one I like. Never mind. Okay, that's the one. So put in a little metal kind of mesh for the, if you want to do that or you want to keep the opaque plastic, it is your choice. Okay, let's, I'll save this and let's take a look at one command here called a clipping plane. And notice how I had to turn off the roof, okay? What if I didn't want to do that, okay? There's an object in Rhino called a clipping plane. You can type it in. It's just like creating any other plane, but this object is special. When it's activated in a viewport, it will clip the geometry so we can essentially see inside the house. So if you turn on clipping plane, pick your clipping plane, go to Properties, and turn it on in well, we're in the perspective view. It looks like it's on You can turn it on in all the views if you want. Go ahead and drag it down and watch what happens. Everything and it helps to do it here, everything that is above that clipping plane is being clipped. So I have a really good way now of seeing inside of the house without having to turn on and off layers. Okay, it is a plane. It does go to infinity, so everything in a viewport is affected. However, if I don't want it to be clipping the front and the right, I can go ahead and turn them off. If I want to just have it clip the top view, then I can leave the others on. You can see how it makes a real nice set of curves for dimensioning. But the curves are part of the display. I didn't really have to create them. They're all just where the clipping plane hits those, intersects those objects. Here's another thing you can do with the clipping plane. You can flip it. So if I flip it, then I'm looking up at the house. Not that you'd want to do that here, but I hope you think that's interesting. I'll flip it back, but take a look at this. I can rotate it and then I can create a section through the house. Okay, so I can look at, the entry here into the shower and how I'm going to move around the kitchen. And I can flip that and look at it from the other side. So it gives us a lot of good information about how these rooms are going to work together. Okay. And I can do a make 2D and it will use that clipping plane, but I can also set up a section view of the 3D geometry in the layout. Okay. And so one other rotate here. So if I rotate it around, no, not like that. Here we go, up here. If I rotate it around this way and flip it, then we can see what's going on in the house in this direction. And then if I turn it off in the perspective view or turn it off in the top view, then it's in the model, it's just not affecting the views. Okay, clipping plane. Okay, let's push forward into creating the layout, and then we will wrap up for the day. If you haven't saved in a while, go ahead and do that. You can also incremental save. If you pick down here, there's a plus, and the plus is one of the options you have for adding a layout. We also have a layout panel, and you can create a new layout from here as well. So I'm going to create a new layout, page 1, sheet 1, that's fine. It will use the Rhino PDF printer, but I'm going to grab an 24 by 18 C-size sheet. 4 details will be the count, and the details, I can put them on a detail layer, but I'll do that later. Let's just, it'll be coming in on the trim layer, but we'll move it to a detail layer here shortly. And if you want to turn off the clipping plane for now, that will be fine. I do have a detail layer, so I can pick the details and put them on the detail layer. I just like them kind of organized on their own layer. One of my preferences with details, which are windows into the Rhino model, I don't like them touching. It's just a weird thing of mine, but I have to do it because if they're touching, it bothers me. So anyway, I always kind of spread them out. The other thing that I like to do here is just zoom in. We'll set the scale here in a moment, but if I double click and make them active, you can see that this one we probably want to put in rendered mode. So when I have it active, I can make it rendered. Okay, so There we go. That looks good. This is the perspective projection. We also have a 2-point projection. So if I highlight the detail, let me double click on it, I can set the projection to 2 points. So here under the viewport properties, we can set the projection to 2 point. There we go. That's real common for architectural. Zoom in so we can see everything. We can also kind of feather that zoom. There is a factor option, and we can bring it in a little bit. Okay, so let's look at these. This one, let's look at the scale because the parallel view ports need a scale, and this one is close to 1 to 48, but I'm going to go ahead and set it to be exactly 1 to 48. In Rhino 7, I can set the detail scale of multiple details at the same time. And there is a command called Synchronize Views that kind of makes them all line up. So Synchronize Views lines them up. This one, though, I want to pan. I just want it to be centered in that detail. So after I get them set like this, I need to lock them so that I don't change the scale. And then I need to set the display mode that I want to see in the detail. So if I go to this one, I'll set shaded. Now these are to scale. Okay, so they're full size. I'm just showing them at 1/4 inch equals a foot so that it'll fit on this sheet of paper. But when I send them out to a PDF and I print that PDF full size, then I can take my triangular scale and I can scale off of it with 1/4 inch equals a foot. Okay, so those are looking good. Let's talk about this one here, because if I turn this one to shaded, what happens? Okay, what are we looking at? The roof, right? So I need to turn back on the C-plane. And when I turn the C-plane on, I can see it everywhere, but I'll go ahead and hide it when we're done with it. The C-plane needs to be rotated that way, and it needs to be applied to the, and let me, looks like it's clipping everything here. There we go. Okay, let's make one up here. On the clipping plane layer, we'll make it the current layer, and I need to view all the layer settings, which look good. Let's make clipping plane the current layer, and let's make one. So the command is clipping plane. When I pick clipping plane, I'll make a box, and this box is the clipping plane. And when you look at it now, you can see it's on in the top view, and that is the only view really that I want it on. I want it on in. So let's grab it here and let's bring it up about 4 feet. I want to make sure and get those windows in there and the door. So anyway, about 4 feet, they say, off the finished floor. And once I have that clipping plane, then I can hide it. And that way I can use it when we're doing the floor plan. And we can keep it. I could also, let me show you the other option. There we go. I can also go to layer and turn it off there, but in order to do that, I need another layer to be current. That works too. Okay, dimensions. You have the option of dimensioning on the viewport, or you can dimension inside the viewport. So if I double click here and I go up to dimension and linear, I'm using my O-snaps here for accuracy. I can create a dimension that reflects the model geometry. And I can create that in the detail. Now, when you do that, you're going to notice that it's also visible over here. So I may want to turn this layer off only in this detail, okay? But leave it on over here and anywhere else where I see it, where I don't want to see it. The other option that we have for creating the dimension is to create it on the layout. And if I use my O-snaps here, notice the dimension is identical. So long as I use my O-snaps, I can create the dimension on the layout or in the detail. Okay, it's up to you. Where you like to dimension. If you want to be able to see them from another viewport, then you'll create them in the model detail. If you only want to see them from the layout, then you can create them here. So let me delete those. And I can also create a chain dimension. So I can create one dimension, and that wall looks like it's got to move over just a little bit, but I can create this dimension, and then I can pick continue, and I can continue it out to the end. Okay, so continue no. I'll create a dimension here, maybe to the midpoint here of the window. Okay, and then we'll continue it yes. Okay, so I noticed that this wall here needs to slide over. So let's just bring that over. Great. And this text, it may be a little bit big, but we can just use the gumball and move it around, take it outside the wall. You can also adjust the size of it if you go into your style, okay? So let's just create a couple more dimensions and then we'll send out the PDF. Continue equals no. Okay, I'll create an overall height and I'll create it from the finished floor to the top of the roof, 17.9. And let's also create a dimension for, the thickness of the slab. If you need to move your text, you can with a grip. Just pick the grip and then slide it over. And let's do another linear dimension here to here. And we might want to also grab the back view and any other dimensions that I'd like to grab, get ortho off. There we go. And near is another O-snap that you can use to dimension to. That way you have the exact location. This one I should probably bring up there. Okay. Anyway, we could do that all day, place lots of dimensions, but those are the basics of creating a layout and adding the dimensions. You could add a title block if you have a 24 by 18 title block. If you don't, you can just add a border and you can shrink it down. And we are ready to add some text. So we can go up to dimension and text block. I'll make this 0.38. It will there we go. 0.25 is fine. Okay, how about we'll call it guest house. Preliminary design. Okay, so we'll underline that and we'll pick OK. Okay, so now we have a title and underlined. Great. Okay. So we can take this and copy it over here. There's one more cool thing that I want to show you. This one is the floor plan, and we can underline it. I also want to add a piece of text, and I'll make it 0.16, so it's a little bit smaller. It will be scale, and I'll put in, for right now, I'll put in 1/4 inch equals 1 foot. And I'll show you what we're going to do with this here next. So, okay, so that's pretty typical. You know, you're going to see a call out for the section and a scale. You can pick that and you can make this a text field. So I can pick FX and I can go here and pick detail scale. I can select the detail and then format it, and it's going to say 1/4 inch equals a foot. And the reason why that's important is if I unlock this, and let's say I change the scale to 1/2 inch equals a foot, notice that that changed. Okay, so that's a text field that is linked to the scale factor of the viewport. So that was new in Rhino 7. And another text field, just while we're here, you can do this in your title block, but you can do something like date, and we can put the date here, and that becomes, I can remove the underline. This will change. So every time I open the file, that date will change. Okay, and we're ready to send it to the printer. So I'll save it. I'll hit print. You can see the preview here. Looks really good. I'm happy with it. And we'll go out to a C-size sheet to the Rhino PDF printer. And I think we'll just name it the same name as the model. And we can, you know, further develop this, add more layouts, add more dimensions, create sections through and detailed drawings from this preliminary. But the idea with this, and I've never ended right at 11 o'clock, so I did pretty good. The idea of this is to give your client or your significant other an idea about what you want to build in the backyard and get their input. So if I come out here to my getting started, and let's show you the PDF that we just created. There we go. Okay, all done during the getting started. So other than a few layers to keep us organized and a couple curves to make sure we all get it in the right location, that is a wrap for today.